Hi everyone, this is Mr. Chu bringing you a special edition of Year 10 Maths through the power of the internet. I'm sorry I'm not there with you physically today, and I hope that this video will suffice. So I'm about to do some teaching the way I normally would on the whiteboard, so please make sure you've got your bound reference ready to take some notes. If you miss anything, I will post an electronic copy of these notes on Teams by the time your class has started. So if you miss something, you can always go back later. All right, so let's get into today's lesson. So today is all about three-dimensional problems. Everything that we've done so far has been in 2 dimensions, but of course, we don't live in a 2-dimensional world. So if we want to apply our knowledge of Pythagoras and trigonometry, we want to be able to do it in 3 dimensions. So really, the way that we're going to be able to do that is to draw a picture, just like we did with elevation and depression problems. And essentially, we're going to break up our calculation into 2 or more steps. And that's it. There's no real content that's new today. It's just that the contexts are going to be new. I guess they'll be 3D. So let's get into it. I want to begin just by briefly reviewing some basic results. So first up, we've got Pythagoras' theorem, which states the following. If I have a right-angled triangle with side lengths A, B, and C, and importantly, where C is the hypotenuse, then we can write the following. A squared plus B squared equals C squared. Given 2 side lengths in a right-angled triangle, I can find the third one by rearranging this equation or substituting values into it. Then we've got trigonometry. So what we said was if we had a reference angle theta in a right-angled triangle, I could label the sides H for the hypotenuse, O for the opposite side, and A for the adjacent side. And if we do that, we will define the following. We will define the sine to be the ratio of the opposite side to the hypotenuse side, and we write that as a fraction, O over H, and remember, this fraction, it means we're dividing. We're dividing O by H. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And many of you will remember the mnemonic SOHCAHTOA. This isn't actually a thing, it's just something that helps students remember it. So this is basically all we need to know. I won't rehearse everything that we've done over the last few weeks, but these are the core concepts at work today. Okay, so here's our first example. I will need to give you a bit of time to get this down. So maybe I'll just invite the teacher who is running the class to pause the video for about 30 seconds so that you can get the diagram and the question down, and then I'll solve it. So go ahead and pause it now, and then I'll solve it immediately after this. Okay, so now that you've got the diagram down, let's make sense of what's going on here. So part A is asking us to find the distance between opposite corners in this rectangular prism. And what we're really talking about is this situation. You don't need to draw this on the diagram, but I want to find the length of this line from one corner to the opposite corner. And the key to doing this is to break the calculation up into 2 steps, both involving Pythagoras' theorem. So what I'm going to do is I'm going to start by finding this line down the bottom, which I'm going to color in green. So here we go. I have a right-angled triangle in the base with side lengths 12 and 8. And just because I can, I'm going to call this length x. Using Pythagoras' theorem, I can write the following. 12 squared plus 8 squared equals x squared. And using our calculator or our knowledge of times tables, we can say that x squared equals 208. Now, I could take the square root of both sides, and that is what we have done in the past. But we don't actually have to do that here. Because my goal is not to find x. It's not to find the green side. It's actually to find this red length here. And that's where I'm going to draw another triangle. This time, I'm going to have the green line as one of the shorter sides, and the red line as the hypotenuse of the triangle. And now what's going to happen is, I'm going to have 5, which is the height of the prism, x, which is down the bottom, and y as my hypotenuse, which is what I actually want to find. So, here we go. We will apply Pythagoras' theorem again. So we're going to say x squared plus 5 squared equals y squared. Now, I already calculated x squared. It was 208. And because of my experience, I knew that there was no need to take the square root here. So we can replace x squared with 208. And now I want a plus 25 to get y squared. All right, and now y squared equals 233, just adding the two numbers together. And now I want to take the square root. So if I take the square root of 233, this is the moment where you do get your calculator. Because I'm on a computer, I'll just use Desmos. So 15.26, I'll round that to 1 decimal place. So that's approximately 15.3 to 1 decimal place. dp is a shorthand for decimal place here. Okay, so that's it. That's all we needed to do to find the length between opposite corners in this rectangular prism, the red line. That's part A. Part B is asking for the angle between the line segment joining opposite corners and the base. So it was good that we drew a triangle, because now we're going to be able to calculate theta quite easily. So let me just duplicate this page. And now I can get rid of that. There we go. Okay, so part B. Now I have this right-angled triangle. The height was 5, so maybe I'll color code it just to make it even clearer. The hypotenuse was red, the base was green, and my height was 5, which I'll put in blue. And it's a right-angled triangle. The base was x, and the hypotenuse was y. And theta is actually here. It's the angle between the red line and the green line. So we actually know all the sides of this triangle. So it actually doesn't matter which trig ratio I use. I should also say that x equals root 208 and y equals root 233. The reason why I'm not using the decimal point, the decimal approximation here, is because I want to use what's called the exact value where possible to keep my answer as accurate as possible. So when I'm back at school, if you're unsure about this, I'm happy to talk about it with you. But if we can, let's keep the square roots and only round at the end when absolutely necessary. So to make this diagram clearer, what I'm going to do is I'm going to get rid of x and y. Don't be upset if you've already drawn the triangle, that's fine. So root 208 here and root 233 here. And our goal is to find the angle theta. We have all three sides, so we can use either sine, cos, or tan, it doesn't matter. Since sine is first in the acronym, let's use sine. So remember, if you forget, you can always label the sides of your triangle. So this is O, this is A, this is H, in reference to this angle theta. Sine of theta equals the opposite over the hypotenuse. So in this case, it's 5 divided by root 233. And you'll remember from our work last Friday, we said that if I know sine theta equals some number, then theta equals the inverse sine of that number. And this is what you would actually put into the calculator. So let's go ahead and do that. Theta equals the inverse sine of 5 divided by the square root of 233. And if I round that to one decimal place, I get 19.1 degrees. Now, we didn't have to do it this way. I could have used cosine or tan. So I'll leave it to you as an exercise to show that theta equals the inverse cosine of root 208 on root 233, and theta equals the inverse tangent of 5 over root 208. And just to convince you, I'll just do the tan one. So inverse tan of 5 over the square roots of 208, and you can see I get the same angle. And the reason why we get the same angle is because I kept the exact values 208 and 233. If I chose to round x and y from part A, there's a chance that I might get a different answer after rounding. So this is mainly of importance if you're going into methods. Try to keep your exact values for as long as possible and only round at the very end. If you're not doing methods, you don't need to worry as much about this. Okay, so that's example 1. I know I've gone quickly because normally when I teach you, I get to ask questions and you get to answer and you get to ask me questions. It's very different by video. And it's certainly a new experience for me as well because I don't normally teach this way. But that's example 1, and we just have one more example, and then we're done with this video. So example 2, we're going to look at a pyramid. So again, I'll invite the teacher who is taking this class to pause the video and let the students take down this question for about 30 seconds. So I'll let you do that now. Okay, so now that you have gotten the question down, just a few things to clarify about this question. This red dot here is directly underneath the apex of the pyramid, and it's directly in the middle of this rectangular base, which has dimensions 10 by 30. And this line here is halfway along this direction. So from this side to this side, it's 5. I could have written all of that in words, but then the question would have become very long, so I didn't want to do that. So we're just assuming that the apex, that is the top of the pyramid, is directly above the middle of the base. So now that we've clarified that, I've given us two objectives in this question. We want to find two angles, x and y, which I have labeled thus in the diagram. Now, we want to find angles, so that means we're going to need to set up a right-angled triangle. So let's begin with angle x. Okay, so that's angle x here, and this is a right-angled triangle. And now the question to ask is, can we label the sides of this triangle? Well, if I start here, it's halfway along the 30. Half of 30 is 15. So we've got one side. The question now is, do we know this side? Well, if you've read the question carefully, you'll see that I've given you the height of the pyramid. It's 50. So I have a triangle with an opposite side of 50 and an adjacent side of 15. And that means we want to use tangent. Tan of x equals the opposite over the adjacent. If I know that tan of x equals some number, then x is equal to the inverse tan of that number. And if I put this into the scientific calculator, I will get the following. Inverse tan of 50, 50 divided by 15. 73.3 degrees, correct to 1 decimal place. In a test, it'll always be clear what precision I want you to give the numbers to. I've just chosen 1 decimal place because I think that's enough. Okay, so that's part A. I'll need to duplicate this page again because I don't have enough space, so 1 second. Okay, so part B. I want you to notice that this is a diagonal line from one corner of the base to the middle. So we're going to need to use Pythagoras' theorem to work out that diagonal length along the bottom there. And the other thing to remember is it's halfway to get to the middle. So I'm not going to use the numbers 30 and 10. I'm going to use half of them. So in the long direction, it's half of 30, which is 15. And in the short direction, it's half of 10 to give us 5. And just remember, I'm finding this length at the moment. That's what I've drawn in green here, in this triangle. Okay, so I've already used x and y, so I'm going to use the letter C because it's common to use C for the hypotenuse in Pythagoras' theorem. So writing an equation, we have 5 squared plus 15 squared equals c squared. You can use a calculator to get 15 squared equals 225, or you might already have that memorized. 25 plus 225 equals 250. And because of my experience, I know that I can stop here. I don't need to actually evaluate this. I can just keep the exact value, root 250. And now I have a situation where I've got this right angled triangle now. And it's going to look like this. This length here is going to be root 250. And this red length here is going to be the height of the triangle. So now I've got y here and a height of 50. Okay. Again, opposite, adjacent. And here's what we want to do. We want a trig ratio with both opposite and adjacent, and that's tan. So tan of y equals 50 over root 250. If you want to simplify root 250, you are free to do so. But because I'm speaking to a general audience, not everyone knows how to simplify a surd, so I'm just going to leave it in this form. Okay? It is 5 root 10. Is that right? Yeah, 5 root 10. But we'll just leave it as root 250. Okay, so tan of y equals some number. So that means y equals the inverse tan of that number, which in our case is 50 divided by root 250. And if we go back to our scientific calculator, we know it's going to be inverse tan of 50 divided by the square root of 250. And the angle we get this time, rounded to 1 decimal place, is 72.5. And I'm rounding up because if the next digit is 5 or larger, I round up. So 72.5 degrees. Correct to 1 decimal place. So I hope you're seeing that all we are doing is calculations involving Pythagoras' theorem and trigonometry to find unknown angles. That's it. So there's no new maths in today's class. The only thing that's new is the fact that we've moved from 2 dimensions to 3 dimensions. And I hope what you've seen is that it's going to be so much easier to do these questions if you draw these diagrams. If you don't draw them, it's going to be really hard. So my suggestion to those of you who are doing this for the first time is, wherever possible, see if you can find a right-angled triangle. Because once you've got a right-angled triangle, then you know you can deploy your tools of Pythagoras and trigonometry. Always draw a picture if you can. It's going to make your life much easier. All right, so let me close by reminding you of what my expectations are for work. If I gave you a worksheet on trigonometry and you haven't finished that, you are free to continue working on that if you wish. If you've had enough of that worksheet, then you can do 8b. I'm going to suggest that if you have not finished 8b, that you finish that in today's class. Hopefully you got some of that done during period 3. And then do 8C, because 8C is easier than 8D. And for those of you who have finished 8D, you are welcome to start an extension topic, which is on the sine rule and area formula. That's not going to be on the test, but if you're heading into methods, the area formula is assumed knowledge in the Year 12 course. All right, so if you're up to date, you are on 8D today, but I understand that as a class, we are all at different places. So, you know, you're almost adults. You're responsible for your own learning. So I'm trusting you to make good use of this class and choose what you think is going to work best for you. If you need help, ask a maths teacher or feel free to message me on Teams. Thank you.